So this is going to be a brief introduction. We're going to talk about data tables, what-if analysis. We're going to talk about one variable data tables, and we're going to talk about two variable data tables. I've got a worksheet set up where I have some input values for a fictitious amount borrowed for a house and some output values based on those input values. So the input values are the amount paid for the house, the deposit made on the purchase of the house, the number of years or the term of the loan, and the annual interest rate. So those are all input values as well as the increment, which we'll get to in a minute when we get to the data table. The increment actually doesn't affect the output, which is displayed down here. The amount borrowed is simply the price paid minus the deposit. The payment I've calculated using the payment function, and I don't want to go into the details of the payment function in this movie. You would just get sidetracked with that. But it generates a payment based on the amount borrowed, the interest rate, and the term of the loan, which are all defined above. The total amount paid is simply the payment times 12 times the years. The payment calculation will calculate a negative number since it's money out. I've converted that back to a positive number for the total amount paid. I just want to display it that way. And the total interest paid for the term of the loan is calculated using the cum iPayment function. And again, I don't want to get into the details of that because we'll get sidetracked with that. But it generates a value that equals all of the total interest that will be paid on a loan, given the values that we've established in the input section above. So I can go into these cells and change one of these values, and my output is updated. So I can change the deposit percentage, the number of years, the annual rate, etc. But what if there's a way to set up a table that shows the output values for changing one of these input values? Well, there is. It's called a data table. And what I'm going to do is set up a data table that's going to display the total interest expense for the changing annual rate of interest. And the way you set up the data table is to reference the cell that is calculating the total interest expense. In this case, it's cell C16. And then for the input, I'm going to begin at 2% and then increase that incrementally by the increment amount, and I'll make that an absolute reference. And then I'm going to copy that down so I have my range of my input for my annual rate of interest. And I've pre-formatted all these cells. That's why it's showing up as a percent. At this point, to set up the data table, we first select the range that contains the input. The annual rate that would otherwise be displayed in cell E7 is inferred. We can fill that cell, but what we're really after, since we know the input already, is 7%. That's what's creating the interest expense of $193,000. What we're really after is the effect of the changing annual rate on the interest expense paid. So select that entire region, go to the Data tab, and in the Data Tools group, left-click What If Analysis, select Data Table, and we get the Data Table dialog box. Now the input for this dialog box can be a bit tricky. Rule 1, if we're dealing with a one-variable data table, we're only going to reference a cell in one of these fields. So which field do we reference the cell in? If we have an input that's displayed across one row, we reference it in the first field, where the cursor's blinking. But we have an input value that's displayed in a column, column E. So we're going to want to reference the cell that column E represents, which is the annual rate. From here, just left-click OK, and the data table is created. So we can see the effect of the total interest paid on the loan of the changing annual rate of interest. And to double check to make sure that it's correct, we can put a value that equals a value in column E, 3%. And we get an interest expense of $74,483, and that's what's displayed in the table. And the table, the output, is dynamic. So if I change the amount paid for the house to $200,000 and enter, my table is updated accordingly because the table is representing the total interest expense, which is calculated on the basis of the input cells. So if I change one of those input cells, the calculated total interest changes accordingly, and it will be displayed in the table according to the value for the annual interest rate that I've established in column E. But what if I want more than that? What if I want not only the total interest, but I want all of these elements as an output? Well, you can do that. I'm going to Control C and go up to cell I6 and paste special transpose those column headers. And then we're going to set up the same structure that we just set up for all of these output formulas. The amount borrowed is in C13. The payment is in C14. The amount paid is in C15. And the total interest expense is in C16. And this time, the variable that I want to change is the price paid for the house. So I'm going to start at $100,000 and then increase that by $25,000 and copy that down. And I have my structure for my one variable data table set up. From here, we do the exact same thing. We select the region that contains the values in column H and the calculated output that's in row 7. And then we go back to the Data Tools group, left-click What If Analysis, Data Table. And since the structure is the same, we're going to reference the column input cell. Since our input is in column, it's in column H. And this time, it's the price that we're determining by the value in column H. Left-click OK. And we get a table that lists all the different output elements, the amount borrowed, the payment, the total paid, and the interest expense for the price paid for the house, beginning at $100,000 and ranging in an increment of $25,000 each to $300,000. Okay, so that's a one variable data table. A two variable data table allows us to change two of the values of the input and generate a table of the output. The structure of the two variable data table is a little different. We first begin by selecting the output. In this case, I'm going to still go with the total interest expense. That goes in the upper left-hand corner of the data table. And since we can do two variables, I'm going to select the variables we've already defined a value for, which is the price. I'm going to Control C, right-click and copy the values for the price. And for the annual rate of interest, I'm going to Control C, right-click, paste special, transpose the values. And we've got our structure set up for our two variable data table. Select the entire region that contains the input values. Left-click What If Analysis in the Data Tools group. Left-click Data Table. And since we have two variables that we're defining, we have two places to input and reference a cell in the data table dialog box. The row input cell is our interest rate, our annual rate, which is in C8. The column input cell is the price, which is in C5. Once again, the row input cell has to do with the values that are displayed across a row, which is our interest rate, and the column input has to do with values that are displayed in a column, column E, which in this case is the price paid for the house. So from here, all I need to do is confirm, left-click OK, and I get my data table filled. So I can see the effect of the changing interest rate, annual rate of interest, and the effect of changing the amount paid for the house on the total interest paid for the loan. These data tables, by the way, use something that looks like a table function, except that it's not really a table function. You can't use the table function to set up a table or anything else. You just won't find the table function. It's some internal functionality for Excel that allows it to set up and display data tables. The other thing that you may have noticed, now that I've clicked on it, is there are curly brackets on either side of the function. That designates this function, and I hesitate to call it a function because it really isn't. You can't use it as a function in some other way. If it was a function and you saw curly brackets, that designates that function as an array function. And we'll be covering array functions in another movie. And just as before in the one variable data table, if we change a variable that is other than the variables that we defined in the table, in other words, we've defined the annual rate and the price, but we can go up here and change the number of years, and the table will dynamically update for that new value for the input. And in fact, we just saw all of the tables get updated. So those are data tables. We first set up a one variable data table that allowed us to establish a range of values for an input variable for which an output was dependent. We then set up another one variable data table that again allowed us to establish a range of values for a variable that it was an input for which a series of outputs were dependent. And then we established and set up a two variable data table that allowed us to establish a range of values for two variables that were input into a series of cells for which an output was dependent. And we displayed the output value and how it was impacted by the changing values of the input variables.